So I guess I got to get together with Michael, you, Luke, and Adam Pausing and get my ZLAB11 fixed. Hey, Mike, I'll touch bases with you after class.
Okay.
What I think Mr. Farm will go over again on the DLAB 11. Show you guys how easy to make it, okay? So listen and question as much as you can to make sure you understand. Okay?
Okay, then. So, under DLAB, you have to get through this DLAB. In order to do few more lab, same way. Now I try to go over, okay? One more time. This lab concentrates on the memory tab. As we already telling you, the first normally to tab we can writing data from port A, 55AA. They go to the U2. In order to get the code to the U2, you have to using the function large, U2 large, and U2 enable. So data can be at the output of U2, and you read it back from U3. If not tab passing, that means U1, U2, U3, and a part of the U4 will be no problem. And now, if we want to testing for U number 8, that's the memory, okay? Normally the way to test for the memory, you write data to a certain address, okay? And you can read it back to make sure whatever you wrote it in, output will be the same. And it part, if they different, something wrong, okay? That is basically the way for the memory. So if you're looking into the circuitry, if you want to write address to the memory, then you have to write to port A, whatever memory you want. You have to let the data go to the U2, okay? So the U2 get the output data here ready. Now you need to get it to the output U5, okay? And that you will apply the clock, okay? So the data will be here. So address already at the input of U8. The next step, you need to writing the data, okay, to the memory. Same way, you have to write data from port A, go into here, let it go out of U2, and now they go to U5, okay? U5, you need to lock to get the data from the input, go to inside of U number 6. Then you have to enable U6. So data already here, okay? And that data will be go to U number 9. That's just a buffer bi-directional, okay? Enable on the time, but the direction depending on pin number 1, DIA, direction. If it's 0, then data go from B to A. That means data write to the memory. If it's logic 1, then data coming out from memory go from A to B. Okay, that's for reading. So this is everything we need, okay, in order to do the lab. However, the important thing here is the software. Okay. In the software here, okay. Let's see. I can tell you. First thing, you have to get the function definition. Now, function prototype declaration for that one. II DLAB, II enable, U5 block, U6 lab, U6 enable, U7 enable. Then the function write address to the memory, write data to the memory, write to memory, read memory, okay? So first thing, you must get that function prototype. I don't care if you understand or not, but you're able to create your declaration for all of your function here. So you get any question when you try to get the function definition for all of this function. We're not talking about what's going on in the function definition, but that is the basically in order to get the program through it, then you must be get this function. I already gave it to you. Only thing is you copy, paste it into your program. Okay, any question on this program?
Mr. Pham, I have another question.
Yeah, go ahead.
Could you please elaborate a little bit how we are using the array of 43 numbers we are using to test this memory? Could you please give a more precise example how we are using it?
For the ADC, right?
Yes, the array of 43 numbers.
Yeah, that will be later. Okay. Right now, I want to make sure, a student in the textbook, if I given you on dot function prototype, can you do it in your program?
Okay.
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 The thing is, sometimes the people still get lost. You can see a difference right here. The void write address to memory. If you're looking into this function prototype, you get the one parameter integer add. Okay, so that is quite different from like II DLAB no parameter. II enable. You see that?
Yep.
Why we need to get the parameter and write address to memory.
Because we're going to pass a hexadecimal number to specify the memory, and then an hexadecimal number to specify the data.
Right, correct. That means when you call this function, you have to tell which address, right?
Yes.
And also the same thing for the write data to the memory. And they want to know which data you want to write, okay? However, the function here, no parameter. The thing does not require any data, anything else. Just do it, okay? That is the first thing. The second thing is now you know when you need to using that function. Okay, now you go back to the schematic. If you want the data go from U1 to U2, that means you need to call the function U2 last. So the loading data here. U2 enable data coming out here. That means you have to really understand the hardware. And now, if I say, I want to write address to the memory, what happens is, you have to write data to U1, and they must be passed to U2. That means you still have to call function U2 LAN, U2 enable. They already here. You want to get to the address here, you need to
clock.
apply U5 clock. That means you understand how the signal going in the circuitry. And the next, you want to write the data to the memory. They still the same way. You have to get the data from here. Go to U2 here. Now go to the U6. And U6 have to be large. data will be in here ready, and you have to get the U6 enable. Okay, so the data will be coming out of U6. So they go in here, going to U9. So U9 pin 1 still have to be 0. So the data can go into the data of the memory. Okay. After the address already ready, data ready, and now you just try to writing that data into the address here. In order to do it, U8 pin number 21 write must be 0. Pin 20 have to be 1. Enable have to be a negative point. 1, then 0, then 1. So the data will be going to that location. That's the process how to write to the memory. Okay. Now, next will be the process how to read data from memory. In order to read the data from memory, then you must be applying which address you want to read. Okay. After you add the address already, then to read pin 21 must be 1. Pin 20 must be 0. Okay. And pin enable
02.
02. So the data from whatever address in here will coming out. Okay. When coming out, so this pin 1 here will be a logic 1. So that coming from A to B. They going down here. Okay. And they will be go to the U7. And U7 you need to enable. U7 data from this side go to the other side. And you get written from port C. That is the process and how the signal going for writing to the memory and reading the memory. Okay. And now the other question regarding it to get the ADC. Okay. Data text. What we try to do, we try to write the data, okay, 43, 42 data of the ADC. Now, if you're looking into the program, okay, first thing, you have to create an array, ADC data. That will be given to you. You cannot make it up. If you do for your own, for the way you want to do different, that means the data here have to be changed. Okay, but now for the program we given to you, I already given to you the first location address will be 99, 2F, and so on, up to 0xFF, that's the last one. Okay, so this address here will be loading into the location of the memory, okay, at the location 0. Okay, now if you go into that function, let's see. You see that function set memory ADC data. First thing, okay, I am using for J0 less than 43. Okay, that means from 0 to 42. So you write the address to the memory J. Okay, that means J0. So address will be 0. J1, they will be address 1, and so on. Then now you say, okay, ABC data equal ABC data per J. So J0, ABC data will be the first data in an array. Then you call the function write data to the memory. That means that data here will be first one in an array, and you write to the memory. So they will be filled on of the data in an array into the memory location. On this one, I already gave it to you. Try to understand as much as you can. So any question? This is the loop. Try to loading on of the data from an array to the location of the memory. Start from 0 to 42 location. Any question? Okay. If it's not, now you will be go into each location in the memory, try to read, make sure the data you wrote it in, they will be the same. So in here, you're still doing the same loop, J0 less than 43. Then first thing you write address to the memory, J0, okay? Then J1, J2, J3. And now expect data. You want that have to be ADC data per J. That means the first one data will be 0899 and so on. And you read memory. That guarantee from location 0 to 42, the data you already wrote it in. Now you read it out, they will be okay. That's for verified ADC data. The thing we're using an array, that will be say the time. You can coding a little line of code. They do it for you. for 42 times. You don't want to write 42 times H1 for each location. That takes a lot of time, okay? And it not make sense. So that's why you need an array.
Hey, Mr. Fan, the ADC is standard for what here? ADC?
ADC data.
Yeah, but
A to D converter.
okay, but here ADC, if we, this is because you are using the same array for other DLAB later associated with analog to digital conversion.
Yeah. The thing is that the data will be right into the converter. That means the first they write data 99.
Yeah, but in this case, it's only a digital data. We're
Right.
not in
But
this.
the thing is, okay, later on, they adding up the circuitry, the converter.
Okay, got it. Okay, and I have two more questions, Mr. Fan, associated to the one is peak clock. So basically, it's a pulse from 0 to 1. So what is the duration of each pulse of those? Is 1 millisecond, 100 millisecond? How do you define the duration of each of those pulses?
Okay, that's what we come up with the converter.
Okay.
That means the one I asked you to load it for the lecture. When you go into a DAAD converter, then you can understand.
Okay, but if that is the case, I guess the temporal scale is around microseconds or something like that. Should be super fast, those kind of clocks.
No, that doesn't mean anything. That the DA converter, that analog circuit.
Yeah. I understand your point, but my question is for instance, the peak clock need a time. So
No, nothing to do with the flip-flop here.
But there is a frequency. It for some time is 0 and for another time is 1 and then go back to 0. So what is the timing for that clock?
No, that's nothing to do with that thing. How come related into the flip-flop here? You write data into the memory. And later on you read it out. And that data will be using for the circuitry next, that will be D to A converter. Okay, for D to A converter, that means you apply binary, output the converting into the voltage.
Yeah, so let me reword my question. I'm talking about the peak clock we apply for U5 pin 11.
U5.
U5 peak clock
Yeah,
apply over pin 11.
Okay, you're talking about
U5.
Okay, just a minute. U5, okay. Now what happened? What happened to U5?
Okay, my question there is, we have to apply a peak clock for pin 11 U5, right?
Yeah, the flip-flop in here.
Yes, sir. So my question is, what is the frequency of that clock? How fast is that clock?
Oh,
What is the duration of the negative phase and the positive phase of that peak clock at U5 pin 11?
Okay, now what happened is you don't care about that thing. Okay, why you care about how fast? Only thing if you get the data ready here, you apply the clock and they go. If you want to know just how long, you have to open this IC 374. See how many picosecond or microsecond just they going from input to the output. But that doesn't affect anything for your job.
Yeah, but the day that we create this circuit, we are going to use a peak clock, and I guess we have to generate that peak clock, right? So
The flip-flop that the IC you cannot generate. You can select the IC. You can view, like 74 374. Or you don't want to using that guy, then you can using the last 373. That doesn't matter. Only thing is, when they get the output here, they stay here. But you don't care from input here, go to the output here. Take how long? That's not our problem. Only thing is, you must understand, when you get an input here, you apply the clock, they go to the output.
oh yeah, I understand that. I understand that. Just I was curious about the property, the temporal property of that peak clock we are applying over on U5 pin 11. As well, the negative pulse we apply on pin 18 U8.
You mean U8?
Yeah, U8 pin 18. There we also we have to apply a negative pulse, right? So it was
You mean pin 8? U8 pin 18.
18. Yeah. U8 pin 18. So
Okay.
how fast is that pulse, negative pulse we apply?
Oh, here.
Yeah. How
Now, in order to write data into the memory, you must get a address ready. You must get data ready. Only thing what you need, and pin 21 must be 0. 20 must be 1. Now, data not go in here yet. Pin number 18 must be 1 on the tab. When you want it to go into data, go into the location here, you put it low and the data going. However, after the data already inside, you must bring pin 18 go to 1. Okay?
Yep.
Reason A. Later on, you change another address, change another data, and they disable, okay, memory. So data cannot go in until you want it. When you want, you have to put in 18 go to low, then data coming in.
Yeah. Yeah, also I understand how U8 works, but my question was again, how fast is that pulse we apply on pin 18?
Now that doesn't matter.
Okay.
You have to normally high, you put it low. Why they low? Data go. And after that, you have to bring it high. That the time doesn't matter. You have to not design the circuitry. We are testing.
Okay. Just I was trying to understand a little bit more about this circuit, but that's okay with me. Okay.
Yeah. If you want it, then you can looking into timing diagram for U8.
Okay, got it.
Okay.
Okay,
for
thank you.
timing, they telling you how many millisecond, microsecond.
Okay.
Okay.
Okay, got it. Thank you.
Yeah, you're welcome. Okay, now I can tell
Hey,
you.
Mr. Pham,
Yeah,
on the AEC, all you really got to do is just copy paste that part that you did, right?
right,
We don't have to do nothing else to that.
right.
Okay, thank you.
from the ADC, you will have to deal with the ADC circuitry. Okay, so that's why I given to you the data I wanted. You just follow it. Now, I can tell you guys how come you get 3 tests for the lab 11. It failed. First thing, enable pin number 18 here. All the time, they must be high if you write data to the memory. Okay, they must be high all the time. Only thing is, when you get the address ready, data ready, you put it low. Then they go high. That only happen for enable, for writing the data. Now, for the reading data, okay, then pin enable have to be low all the time if you read. The thing is, when you read data that's coming out, depending on whatever address here, data cannot coming in. So that's why they cannot screw up inside the memory. Okay? That's important. And next, also, the problem here. If you want to write data to the memory, then you go in U1, U3, and U6. U6 here, you need to get the U6 large. So whatever data input here go in here. Then you have to get U6 enable. Data from inside go to the outside. Okay. U6 enable, that means pin number 1 will be 0. That enable U6. Pin number 1, 0. And that will be get U9. Pin number 1 also 0. Data can go from B to A. Ready. Okay. You get the problem here. A, when you write data to the memory, okay, your function enable U6 something not right. So that's why data cannot be here. Now I give it to you. Okay, in this one, I already showed you. We need to modify something. Okay, port B, pin 6, that means pin 20 in the memory. Pin 9, pin 21, memory right. Okay. When you say U6 enable, U6 enable, that will be telling you data will be ready here. Okay. And they're supposed to be go to the US data. So in order to correct the problem here, what you think U6 enable right now in your program? What data? Your guy already done it. I asking you what data on your function definition U6 enable.
Actually, on my one, I have 0x01 because I didn't do the memory G, because that part I take care of when I write to memory.
Okay, now when U6 need to be enabled,
Mm-hmm.
if you're looking into here, you can say U6 enable. That means you want the data will be right into the U8.
Right.
Right. The thing is data from memory that coming from U6 output. So when you say U6 enable, what you need make sure you get pin 21 have to be 0, pin 20 have to be 1.
But that's when you're ready to write, right?
Yeah, the thing is you write data to the memory that coming from U6. U6 is the data for the memory.
Right, but the thing is, don't you write it when you do your write to memory function?
No. The thing is, the big problem in here, if we sharing the pin for port B.
Uh-huh.
So when you go to U6 enable, then you make sure that at that time, memory pin 1 must be 1, and memory write have to be 0. If you not, what happen is, you call the function U6 enable. Later on, you have to set this to 1, right?
Mm-hmm.
This to 0.
Right.
But you ignore enable U6. So that's why data cannot go.
Well, when I do the write to memory, yes, I ignore it.
Yeah, I guarantee.
120.
Right. You ignore 0, 1 here.
Right.
So that's why you disable U6.
So data is no longer there, is what you're saying.
Right.
Okay.
Okay. So now what you need to correction is U6 enable data supposed to be 2, 1.
So let me see if I get this right. Can you go back to the schematic? So what you're saying, okay. What you're saying is when we enable U6, we have to make sure U8, pin 21 and 20 is on right.
Right.
And then the other one is on high, which is input, right?
Right.
Input. So therefore, even though we haven't applied the clock through the port D, it will still register that number at those pins. Is that correct?
Yeah, the number here, if you write to port B.
Right. If we write 10 there, okay, or 01, sorry, for 5 and 6, 01, okay, and then all the data that's coming into the port D on the right-hand side of U8.
Yeah, if you enable U6, data will be ready here.
Right, U6 here, then it'll go through U9 to U8.
Okay.
Now, once it's there, okay, you're saying unless we put pin 5 and 6 to 0 and 1, the data will not be available once we change U6 to disable output.
Okay. Now, in order to get the data go here, you have to enable U6, right?
Yes.
Okay. When you say you write to the memory, you enable U6, they already here.
Mm-hmm.
However, in the function definition write to the memory, then you must be set pin 21 to be 0,
Mm-hmm.
20 to be a 1. Right?
Mm-hmm.
That means you write to port B.
Right.
You write to port B, but you ignore enable here.
Mm-hmm.
So no more data here.
So what was there before will stop. So therefore, no data no longer coming out. Hence, there's no data at the U8.
Output here.
No data there.
Right. So when you apply the negative post enable,
Mm-hmm.
data coming in on 1.
Okay.
Okay?
Yep, I got you. Thank you.
So in order to correct the problem, what you need to do, you have to correct your function definition for enable U6 0x to 1.
Mr. Pham,
Yeah.
is there a chance that you show again on your code how you implement that? I understand that it's necessary to enable U6 have 1 on G and 0 at W of chip 8, but it still is not clear to me how to translate that into the code itself.
Why you need to enable U6?
I need to enable U6 to allow to get out to okay, I have to do 2 things with U6. I have to latch U6 and then
that we already done.
okay,
but my question is, why you want enable U6? That means you want the data will be go here, right?
yes,
And go here.
yep.
Okay. So in order for data going from here to here and guarantee U6 must be still enabled. If you apply for port B here and you skip the U6 enable, then the data cannot go.
No, yeah. I understand that explanation using the schematic. I understand that how the circuit is working at the level of the schematic. My question is, still is not easy to me how to translate that from the schematic into the C++ code. So my question was if you can show how you implement only that portion in your code.
Okay, now, if you can see, first thing I will be changing okay, function definition, U6 enable. U DLAB to enable. Okay, now.
There.
Okay, U6 enable. Okay, U6 lab. That's okay. U6 enable here.
Yeah.
Data write. Okay. If I say write to port B 01, okay, that means they can get out to the U6. You see that?
Yes.
No problem. However, when I go to the write data, write to memory, this is a key point right here. Write to the memory, okay? I have to write to port B, Q1.
Okay.
Okay, Q1, that means what?
Okay, got it.
Okay,
Yeah. Thank
So-
you, Mr. Pham.
either if you changing from U6 enable to Q1, okay, in here, Q1, then inside write to the memory, okay, let's see, write to memory here. Then instead you have to type in line 317.
Mm-hmm.
You just go U6 enable. Same thing. Okay.
Okay.
Mr. Pham, so you said if we write 0x21 when we do the U6 enable, then over here, we can actually do it with 0x20 then. Is that
Right.
is what you're saying?
Right.
Okay.
If
So
you
there's two
want,
ways of doing it.
I can tell you. Okay. Now, if you want it, I think you can change U6 enable here
To 2-1.
to 1. Okay.
Mhm.
Now, if you're using to 1 here, so in write to the memory, instead you write that one. You don't have to. Okay. You can
write-
using U6 enable. You call this function, right?
Mhm.
Then you don't have to do on that one. Either way,
Okay. But then on your other sheet, if you go down to when you write, you got 0x20. If you go back to your other sheet with the ports,
go back to where?
the other sheet, the ports, that show you the port, which pin and so on.
Schematic.
Not the schematic, the other one.
The TXT, you mean, Michael?
Yeah, the other one where it show you the pin port B, port D of the pin.
The TXT file, Mr. Pham.
Text file.
File.
What the pin number? What U number?
No, you got three screens. Okay, there's the schematic, the code, and then there's another one that show you the procedure. When you write to memory address, you do U2 large, U2 enable, U5 clock. Yes, not the help port. The help or no? There's another.
Only thing.
This
I
one.
don't
No,
have anything in the port.
it's a text file.
Look under the text program, the test program,
Text.
the test program. Look, scroll up and down.
Okay. What you want to see, the text?
No, on the one where you're trying to help us show us port B, pin 1, 2, 3, 4, and then we put in
Okay,
what
that
was
one on.
0 or 1.
I try to see where that mine.
Mhm.
You're talking about that one?
I don't see it. I'm still on this spreadsheet.
Yeah, that one there.
Okay. Now on the top here, you're saying U6 enable 0 times 2, 1, right?
Right. That's what we need to change.
Right. Now go down. If you go down, and okay, when you write to port B, oh, you changed that one to 2, 1. Okay, because on the last time when we did the class, it was 0 times 2, 0.
Okay, so that's why we draw.
Okay, so you change it to 0 times 2, 1. Okay, all right, thank you.
The thing is, the problem here is when I did a new circuit, we just build it and we try to write the program. And after you did it, we tested it failed. Okay,
Mhm.
that took me for a while to figure out what happened. Okay, so that's why I'm telling you.
Okay,
Okay, so basically in how to write to port B and port D. So basically, if you're using U6 enable, then you don't have to write to port B again. However, now, this is another thing. When you write to the memory, I already telling you, pin number 2 will be memory enable. Every time before you want to writing data to the memory, they must be 1 first. Then they be 0. Then they will be 1. And also pin pin 1 enable is 4B. I don't want 0. I want have to be 1 all the time. We don't need to enable that. So you must be correct in here. Write to port D when you want to write to the memory. They have to be 0, 3, 0, 1, and 0, 3. If you not get the same, correct it.
okay, got it. Okay,
Okay? And now, how to read memory. There's nothing changed on that. Okay?
1, 2, hang on. 1, oh, that's changed. It's 1, 2 now. It used to be 1, 0. And then 0, 1.
Hey, Mr. Pham,
Yeah.
you said you had a hard time writing the program, and you said the circuit was changed. So should we look back at the web and see what you changed on? You changed the circuit.
Oh. That is how do we change the circuitry?
Because if you change the circuit, yeah. Okay.
Right. I change the circuitry here, adding U9.
But that was there before though.
No. That not happened in the past.
Oh, in the past, okay. Because I got it originally and I printed out, U9 still there.
Yeah, they still be there, but the thing is, in the past lab for the textual, they don't have a this circuitry.
Right, right.
It didn't go to U9. It went straight to the data, correct?
Right.
Right.
Okay. Okay. Scroll down some, Mr. Pham.
That was DLAB9.
Okay, right there. And you took out one of the inverters as well.
Right, that's a different.
Yeah,
Yeah.
but we were not using that one, Mr. Smith.
I know. I'm just confirming everything. You had three inverters, and now you have two.
The thing is that we're not using.
Yeah.
Okay. Yeah. I'm just making sure. Because
Okay.
every time you change the circuit, you got to change your program.
Right. I tried to add in U9 245
245
to
bi-directional.
get for you guys to understand another type of the buffer, but bi-directional.
Right.
Okay.
Most of the time, the buffer go one way.
Right.
But in this case, the buffer, the 245 buffer is a bidirectional buffer, means it goes two ways.
Right,
Because most buffers go one way only.
right. Normally, this I see using a lot in most of the circuitry. If you're using the buffer only one way, you have to using two IC. One for in, one for out. That's what we did it in the past.
Mhm.
Now we try to using the 245. You need only one IC.
Hey, Mr. Pham, can I ask you a question? You don't need to go into a lot of great detail. Did you notice, because I saw it on the news, that there's a shortage of ICs, integrated circuit chips? Because like when you go to the store, a lot of them, they're out of them. Have you found that to be the case?
No, doesn't matter. Whatever we need to design, we design. We don't care shorted or not.
Okay.
Or not be used,
Okay, I got it.
not be available anytime. Okay, so far, look like you guys can control the circuitry now. You understand it,
Okay.
okay?
Yeah.
That is perfect.
So
The thing is what could happen next. This circuitry here, maybe look like this one, maybe not, but the concept will be the same.
Mhm.
And the output, they will be connected to the circuitry we call D to A converter. Okay? And a D to A converter, that means they will be converting from analog digital to analog circuitry. Just a minute, I can show you.
digital to analog and analog back to digital.
Right. This is a next lab. This lab not using the memory.
Yeah, digital analog converter.
Right. Now, this lab, you already know both of the IC. This is a 74191 binary counter. Another binary counter. Okay? And they go to the U4. That will be D to A converter.
Digital to analog.
Right. Input is binary.
Right.
Output for this DA converter will be converting to the current output. And we don't using to work with the current. So that's why they're adding this circuitry here.
Op amp.
Who knows what the name of this op amp here? What circuit look like?
Inverter amplifier.
Inverter,
Amplifier.
yeah, but what type of the amplifier? Basically, this circuitry,
Is that the one you call sample and hold?
no, this circuitry will be converting the current here from the U4 back to the voltage. That's what they call a current to voltage converter. So if they're coming out 2 milliamp here, they multiply by 5K. Okay, so the output here is supposed to be 10 volt. You see that?
And,
Yes.
and Mr. Pham, that's based on what you have at on U4 pins 5, 6, 7, 8, 9, 10, and 11.
Right here, right?
Right.
That's a binary.
Right. But when you
If you get data one here, that means full scale.
Right, full scale.
Output supposed to be 10 volt.
Right, exact. There we go.
In order to get a 10 volt, that means if for not giving you the voltage out, they given you the current out. Current and maximum 2 milliamp here. So you have to add in this circuitry outside to converting to the voltage. This circuitry will be called current to voltage converter. So if you get a maximum 2 milliamp, you multiply by 5K, you're supposed to get 10 volt. Okay, so basically this lab just for basic DA converter. You program the binary input, you connect the meter into the output here. If you set 1, 1, 1, 1, 1, 1, 1, you measure the output supposed to be 10. Okay? And you change the binary here. You measure the output have to be equivalent to whatever we can here. When you're learning DA converter, I already give it you guys here now. Then we will know how to calculate the current out. You multiply by 5K, you get the voltage out. So that will be D to A converter. Binary coming in, analog coming out, but not analog voltage, but analog current. So we don't try to measure the current. That's why we have to add in this circuitry. So next time we're learning DA converter and AD converter. We'll be explain more things in here for you. For your guy, just a technician. That means you apply on one here. You suppose get a 10 volt here. If they not 10 volt, how can we fix the problem? That's what I try to teach you. Okay? So if you understand what's going on each one in here, then you can make the correction. Okay, any question? So now I can let Mr. Fan try to correct the program for your guide, DLAB11, and run it. Okay. Hello, Mr. Fan.
Yes. Want to run the program as a DLAB11?
Yeah, correct that and run.
Oh, I'm not correct that. I'm going to run the one, the good one. I'm not going to run that. I said you guys are going to change that and submit it later. But I run the good one to show you what we did is that program run okay. Okay.
Okay.
So you have to correct it. Now let's set my screen first. This is a program after we update the instruction.
So I think you guys can get it lab done quickly.
Mr. Pham, is there contact information for Mr. Hong Pham? Because if we upload the data, let's say if I work on it tonight and I get an upload tonight, I don't
Yes.
really want to wait till another week before finding out it failed. So is there a way we can maybe Zoom with him and then he can run it and then say,
Okay, I understand. I tell you, try to make sure upload any program they upload into the DLAB tool, DLAB Protect tool,
Section 2.
right? And run it right away and let them know.
Okay. As long as I can see it, it's the better way that you upload and then you send me an email. I check email every early morning.
okay, and then
Okay.
back to us.
You just give me a note. Oh, I correct and upload a DLAB11. That's all.
Okay, all right, thank you.
You're welcome. And if possible, you can put like you upload the DLAB11 and put a date in there. So it may be different with the old one. Okay?
Yes, I usually put a date at the end of the file. So
yes, or version A, version B, version C. So I don't have to open too many of them.
right.
Okay?
No, I put a date on it so you know.
Yes, anything to identify the list that you have upload.
Okay, thank
I
you.
will check that.
Hey, Mr. Pham,
Yes, sir.
do you mind, like, when I do the new ones, send it to you on the notepad on text?
Oh, notepad, anything, just a text or whatever. cpp.cpp, okay, .txt is okay. Upload, then I run it first.
Okay, thank you.
Yeah, but at least you need to flag me. Oh, I upload by email. If not, then I have to wait until like afternoon. I have time, then I go in to check upload. Okay. But if you email me, I check email early about 8 o'clock and then I see, hey, here, it's submitted the upload. So I'm going to check the upload and then I pull out, I ran it. Okay. It's an easy way to do it. Just make sure is I see the new upload. Okay. Somebody just got it, upload that one and keep the same thing, same file and keep uploading.
And make sure you update the status, and on Monday, you can let them know.
Anytime when I have it and the following day I chat on the Zoom is a meeting, I tell them it's all pass or fail right away. Okay.
They should stop the program. We don't need to run
Okay.
even.
So this one should be okay up to the end. Okay. When it's reading it address in the memory twice it pass and then the following will pass. Okay, I stop it now.
Okay.
And I return the screen to Mr. Pham. And remember that, just give me a note and say you already do something with the DLAB11. And I have it, and then I ran it right away, and I let you know the following. It's a Zoom meeting, pass or fail, okay? or I can return on your email. But I'm not sure it's a you reading email, but I will do what I can do after I run your lab. Pass or fail, either I send you an email, I reply your email, or I chat on the line at the Zoom session the following day. Okay?
All right.
Okay, but I want on Monday. Please, you can read give the status of II DLAB.
Okay, it's on the Monday only. I will have that one for you.
Okay. Okay, any more questions? If it's not, then good night, everyone.
I have a question for Mr. Fan Big Boss. Is there a chance that you teach us a little bit how to program microcontrollers?
No,
Only one or two classes, Mr. Fan, please.
now the thing is that you want that, I need to talk to Mr. Tai.
Okay, okay.
Okay, he did it, not me. Okay,
But okay, but maybe you can ask him, right?
yeah, I asking him. I want to do it also. But
Okay, you can be in the class with us, Mr. Pham, and then you'll know how it is when you ask crazy questions.
okay, good night.
Good night.